Hello again everyone, this is Vincent and this is episode 12 of the Steambirds survival Let's Play on Kongregate. Yes, it's been a long time since my last video. Apologies for that, but it's just real life, study and stuff like that getting in the way. And since I don't have any more ideas for commentary, it looks like I'll be doing more academic stuff again, revising and jazz. Today's video is going to be on organic chemistry. Which is basically a subset of chemistry where your main compound of study is carbon, has a lot of carbon in it, lots of hydrogen, a bit of oxygen and nitrogen maybe. I can't cover all of them because it's very big. Carbon tends to bond to itself very well, forming very complex structures. So I'll just cover a few compound groups. In this time, alkanes, alkenes, alkynes, and alcohols. Alkanes basically just have a long carbon chain, all single carbon-carbon bonds, and the rest of the bonds are carbon-hydrogen bonds. They're pretty unreactive because of the stability of the carbon-carbon and carbon-hydrogen bonds. They have high bond enthalpies, or you need a lot of energy to break the bonds. I think all organic compounds can undergo combustion reactions, reacting with oxygen to give carbon dioxide and water. The only other reaction which an alkane can undergo is a halogen substitution. Basically, you have a halogen such as bromine, and using a free radical mechanism, it will attack one of the hydrogens on a carbon, and it will replace it, forming a haloalkane, which is basically a carbon chain attached to a halogen. Pretty boring. The next group is an alkene. Now they're more interesting because their functional group is a double bond, which is quite reactive and will readily break to form different types of compounds. One of the compounds they can form is one of the reactions they can undergo is a addition reaction where you add a diatomic molecule across its double bond by breaking the double bonds. So now you have a carbon-carbon single bond, and the new bonds which the carbons can take are replaced, have an atom added onto it. You can add a halogen across it, which will each of the carbons, instead of being double bonded, are now attached to one halogen each, forming a dihaloalkane. You can also add a hydrogen halides, such as hydrogen chloride, hydrogen bromide, and so on and so forth. Again, you break the double bond, and you add the hydrogen and the chlorine to each of the atoms. So now you have a single haloalkane, a haloalkane with only one halogen. You can also add hydrogen across the double bond on the condition that you have a finely divided nickel catalyst to speed the reaction up. And this process is known as saturation, where you remove as many double bonds as you can and try and add as many hydrogens as you can to the carbons. You can find this in food technology, where you saturate vegetable oils to make margarine, to make it feel a bit creamier, or whatever butter feels like, and give it a high melting point. You can also add water across the double bond, which will give you an alcohol. But the conditions are you need a high temperature, so around 300 degrees Celsius, high pressure, so around 7 atmospheres, and you also need and it's advised you have an acid such as sulfuric acid or aluminium oxide catalyst to speed the reaction up. And by adding water across the double bond, you add a hydrogen to one of the carbons and an hydroxyl group to the other carbon, forming an alcohol. The last reaction you can do with alkenes and their derivatives are polymerization reactions, or addition polymerization. There's another type called condensation, but I won't go there. Basically, again, you break the double bond, but instead of attaching each of the new bonds that the carbon can form to two atoms, you can attach it to two molecules which have broken in the same way. And because each end can keep going and going, you can form a very, very long carbon chain. So if you just take ethene, you break the double bond, it attaches to another ethene, which has the double bond broken in a similar way, and that keeps going and going, forming polyethene. You can also do it with other compounds with carbon-carbon double bonds with another functional group attached, such as polystyrene, which is ethene, but one of the hydrogens has been replaced by a benzene ring. Polyvinyl chloride, it's been replaced by chlorine, and other things like that. There are alkynes, they're just triple bonds, you can add a hydrogen across them again. We don't go into too much detail about them. The last one I'll talk about is alcohols. You're pretty familiar with them. You can get them through organic processes such as yeast fermenting sugar in the absence of oxygen to form ethanol. The main type of reaction you can do with an alcohol is a oxidation reaction, and depending on the type of alcohol it is, you can get different products. Tertiary alcohols, where the carbon which the OH group is attached to three different carbons, don't oxidize readily. Only oxidize using oxidizing agents such as dichromate ions. Secondary alcohols, where the carbon which the OH group is attached to is only attached to two others, will only oxidize to a alkanone, otherwise known as a ketone, where there is a carbon in the middle of the chain which has a double bond to an oxygen, and it won't oxidize further from there. The primary alcohol, where you have an OH group attached to a terminal carbon on the or a carbon on the end, will oxidize to an alkanal, otherwise known as an aldehyde, and if you're doing this reaction, you can extract the aldehyde by distillation, or if you do not, the aldehyde will readily oxidize again to form carboxylic acid, otherwise known as an alkanoic acid. And if you're only looking for an alkanoic acid, you can extract it by you can make sure that you can extract all of it by using reflux, where you can keep the reaction at a high temperature to speed it up, but by reflux you stop any escaping by evaporation by condensing it and making it fall back into the reflux chamber. Also, alcohols can undergo elimination reaction, which is you have an alcohol and that will revert to an alkene and water, which is basically the reverse of the alkene having water added across a double bond. Instead, you have to have atmospheric pressure. It's basically the reverse of the reaction, so you can have the catalyst again, and you can form the alkene. Okay, I've gone a bit quickly this time. I've got a minute left. I might just go into some. What's next? Aldehyde. No. Oh, esters. Basically, esters you just create by reacting a alcohol with a carboxylic acid. They usually have a sweet smell. Anything else interesting? Oh, there's some other conditions you need, but I'm a bit short on time now. Just got 20 seconds, so I'll see you in the next video when I can make one. Please drop a comment on what to do for a commentary if you don't like listening to me talking about this. I'll see you in the next episode then.